Alright, one other thing that needs clarification is this question of transferring between two tubes. And I've been saying transfer source to destination, but that's not really what's happening in the current version of the simulations. We can do versions where we actually have a directed transfer, but here's what we're working with right now. Let's look at this tube right here, and suppose that the amount of source is equal to 12 and the amount of destination is equal to 27. We would say that corresponds to a transfer between tubes 12 and 27, but it's not really that straightforward. So let's put some chemicals in 12 and 27 to begin with. So here's some source over here, and some source over here, and here's some destination, and here's some other destination. So these are just for the sake of argument. Suppose that this is the composition of tubes 12 and 27 at this point in time. When we find the 12 and 27 concentrations in here, it doesn't cause a transfer from 12 to 27. Think of it as connecting these two tubes through some sort of conduit. It's connecting them with something that allows chemicals to flow between the two tubes. And the flow is based on the relative amounts of chemicals in each tube, so it's sort of physically inspired on the idea of concentrations. So if over here we find a lot of this blue chemical, and over here we find a little bit of the blue, then this connection will cause some blue to transfer from here to here. In other words, the destination value of this tube will drop, the destination value of this tube will increase. At the same time, since we have more of the red, the source over here than we do here, some of the source chemicals will transfer over to here. And so what's going to happen is over the next short period of time, we're going to find some of this blue turn into blue over here, and some of this red is going to transfer over to here. And these tubes are going to tend to move towards an equilibrium state. Now, the rate at which they transfer is based on the relative differences in the amount of each chemical on the two sides of this conduit. And so, if we have the same amount of fluid in both sides, the same amount of source on both sides, the same amount of destination on both sides, then this becomes a no-op. No transfer takes place. And as I said, that's one way to do this. We can have another version of this where we actually say, take chemicals from here and transfer them to there because of the source destination. That's something we can change the code very easily to work with, but the system we're working with right now works on these relative levels to decide how the fluid flows. The bigger the difference in amounts in the two, the faster the flow rate's going to be.